A warm greeting to one and all, and welcome to our tutorial Programming Logic and Technique with Programming C. In the today's sessions, we are going to discuss about the iterative process statement called as while loop. So in the last session, we have covered many problems which were based on what? A for loop. We have also covered and we have discussed about the break and continue statement. So in the today's sessions, we are going to discuss about the iterative process statement called as while loop. And first of all, we will discuss why while loop, then when to use a for loop and while loop, then the format of while statement, then we will discuss about the while one statement, which is also referred as a while true statement. Finally, we will discuss the synonym of for loop to while loop. Okay, so these are the things that we are going to discuss in the today's session. So let's start with the why while loop. So let's define what is loop. Loop do exactly what they sound like. Okay, that is, they allow us to run the same set of instruction again and again while the condition is what? True. Or you may say that they will execute the set of instruction as long as the stopping condition is not going to meet. Okay, so this is what your entry point of execution of this particular group of statement, and this process will be continue as long as the condition is true. The moment condition become false, the control will be transferred to the next statement that follows a looping statement. Okay, so whenever you are doing or executing a piece of code for a certain counting times, okay, then always use what? A for, otherwise always go with a while loop. So we will illustrate with an example in our next slide. So when to use a for loop and while loop? Use the for loop when something is deterministic. It means you know in advance the how long the particular statements are going to be executed. That is something that is countable or iterable with a known quantities. Okay, and use a while loop for something that is not a non-deterministic. It means keep doing something until one or more condition is going to meet. So I will take a very simple example. Okay, assume there is a container. Okay, and in that it contains certain chocolates. Okay, and if you are asked one of the kids to pick up 10 chocolates, okay, at a time only one. So how he is going to do? He will take first chocolate, then second and third and so on up to 10. It means we are assuming here that there are at least 10 chocolates in that particular box. It means it's a countable. Now, if you put the condition something like this, take the chocolate as long as the box is not going to be empty. Okay, so what is the condition? As long as the box is not going to be empty. It means that in that particular box, it may contain 2 chocolate, 3 chocolate, 10 chocolate, 15 chocolate, 50, 100, we don't know exactly. Okay, so in such situation, you are going to use what? A while loop. So I hope that you understood a difference between what? A for loop and while loop, and when to use a for loop and while loop. Now it's time to discuss the format of the while loop. So it's very simple. Okay, so what? While condition, the statement inside the body of the loops are going to be executed one after another as long as this condition is not going to become false. So let's see. First of all, the while loop evaluate the condition, that is also referred as what? A text expression. If the condition is true, then the statement inside the body of the loops are executed one after another. Okay, and then the condition is evaluated again, and the process goes on until the condition is evaluated to false. Now here you need to remember one important step, that there should be a statement inside this loop, say reinitialization, which will make a new value closer to condition. Otherwise what will happen? It will remain continue forever. It means in that case it will become an infinite loop. So there must be a certain condition which makes at some point this condition a false. Okay, and finally when the condition becomes false, the control will be transferred to the next statement that follows a while loop. Okay, so I hope that you understood the working of while loop. Now it's a time to see some certain problem based on a while loop. To find the sum of each digit of a number, what we need to find out? The sum of each digit of a number. So it means your number may be consist of 2 digit, 3 digit, 4 digit, 5 digits. We don't know in advance how many number of digits that a particular number is going to be contained. Okay, so initially assume the value of sum is what? 0, and accept the value of n. Assume it's a 1234. Okay, now whether the value of n is greater than 0? Yes, 1234 is greater than 0. Condition is what? True. So in that case, what you need to do? You need to perform these 3 steps. What is that? First of all, find out the remainder. So what you will get? Number 4. It means 1234 divided by 10. Okay, so you will get what? A remainder 4. It means what you have done? You have extracted this particular number. It means you got a 4. Now perform the sum. Since we need to, what we need to do? We need to find out the sum. So 0 plus 4 is what? 4. Now once you have extracted the number 4, the next thing is what? You should have only 123. So how it can possible? That is 1234 divided by 10. It's what? 123.4. So integer of that, it's what? 123. Okay, now again go back to the loop. 123 is greater than 0. Yes, condition is true. Now 123 mod 10, remainder is 3. So previous sum plus 3, it's a 7. Now 123 divided by 10, 12.3. Okay, so integer of that, it's a 12. Again go back to the loop. 12 is greater than 0. Yes, condition is true. Now 12 mod 10, remainder is what? 2. Now previous sum plus remainder, that is, it becomes 9. Okay, now 12 divided by 10, it's a 1.2. So integer of that is 1. So 1 is greater than 0. Yes, again condition is true. Now 1 mod 10, remainder is what? 1. Always remember, whenever the numerator is less than the denominator in modulus operator, the remainder will be always what? Numerator itself. Okay, so previous sum plus remainder, 9 plus 1 is a 10. Now this is the most important step. 1 divided by 10, it is what? 0.1. So integer of that, it's what? 0. Now this is the most important step. Now 0 is greater than 0. No, condition is what? False. Okay, when the condition is false, what you need to do? You need to display the sum and stop. Okay, so remember, this is the most important statement. This process will be continue as long as the value of n is greater than 0. The moment if it is less than 0 or equal to 0, control will be transferred to the next statement. Okay, now what if at initially if I have written here while n is less than 0 instead of n is greater than 0 and assume the value of n is what? 1234. So 1234 is less than 0. No, condition is what? False. So it means the control will be transferred to this part. It means we are not able to give the guarantee that the statement that you have written inside the loops are going to be executed minimum one time. It depends upon this condition how long these statements are going to be executed. Okay. Now to find the number of digits in a number, okay, we need to find out the number of digits that holds in that particular number. So initially assume the number of digits are what? 0. It means we are counting. Okay, then accept the value of n. Okay, assume again it's a 1234. Now number is greater than 0. Yes, condition is true. Okay, so you are going to perform these two steps. So increment the counter digit by 1. Okay, and find what? The next number. Since you have already divided this number by 10. Okay, so what you need to get? You are going to get a next number. So 1234 divided by 10, it's what? 123.4. So integer of that, it's a 123. 123 is greater than 0. Yes, again increment the number of digits by 1. Then 123 divided by 10, 12.3. So integer of that is what? 12. Okay, 12 is greater than 0. Yes, again condition is true. So previous sum plus 1, it means the number of digits has been increased by 1. Now 12 divided by 10, it's what? 1.2. So integer of that is 1. Now 1 is greater than 0. Again condition is true. So increment the counter of, that is the counter digits by 1. And now 1 divided by 10 is what? 0.1. So integer of that is what? 0. Now 0 is greater than 0. No, condition is what? False. So now here what you need to do? Print. You need to print the number of digits in that particular number. So in this case it's what? It's a 4. So it means again if your number of digits contain 5, you will get what? This process will be continue how many times? 5 times. If it is 6, it will continue this statement up to 6 times and so on. Okay, and finally stop. Now to find the reverse of a given number, assume the number is 123. So reverse of 123 is what? 321. So how to get it? Let's see. Initially assume the reverse value is what? 0. Okay, so accept the number. Now assume the number is 123. Okay, now perform this process. What is that process? Check whether the number is greater than 0. Yes. Now perform these 3 steps. So first of all, find out the remainder. 123 mod 10, you will get what? 3. Okay, so what is the initial value of reverse? 0. 0 multiplied by 10 is what? 0 plus 3, that is your remainder. So overall value is what now? 3. Now 123 divided by 10, it's a 12.3. Integer of that is what? It's a 12. Okay, now 12 is greater than 0. Yes, condition is true. Again find out the remainder. 12 mod 10, remainder is 2. Previous sum is what? That is previous reverse number is what? 3. 3 multiplied by 10, it's a 30. 30 plus 2, 32. And again 12 divided by 10, it's a 1.2. So integer of that is what? 1. And now again go back to the loop and check whether 1 is greater than 0. Condition is true. And once again find out the remainder. 1 more 10, it's a 1. Previous reverse value is what? 32. 32 multiplied by 10, it's a 320. 320 plus your remainder, that is 321. And now 1 divided by 0, it's what? 0.1. So integer of that, it's a 0. Now 0 is greater than 0, no, condition false. So execute the next statement. So what you are going to do? Display the reverse number. So reverse of 123 is what? 321 and stop. Okay. Now to check a number is palindrome or not. Okay. So what is palindrome number? If the original number and its reverse numbers are same, then such numbers are referred as what? A palindrome number. For example, if the number is 123, reverse of 123 is what? 321. So 123 is equal to 321? No, it means that number is not a palindrome. Okay. Now take another example. If the number is 121, so reverse of 121 is what? Again 121. So on comparing the original number 121 with the reverse number, in this case it is a true. So it means that number is what? A palindrome number. Okay. So initially the value of reverse is what? 0. Accept the value of n. The first few steps are the same that what we have seen in our earlier algorithm, except this new step. Observe that in the previous case our original value is, we are losing our original values inside the loop. When the loop terminates, what is the value of n? It's a 0. Okay. It means what we need to do? We need to preserve the original number. Now why to preserve the original number? Because at the end we need to compare your reverse value with the value that you have accepted. But we know that during the execution of the looping statement, the value that you have accepted is going to become a 0. So that's why we need to preserve the original number, and for that purpose this statement has been written. Okay. So assume the number is 121. So original number is also what? 121. Now perform the same step that what we have seen in the earlier algorithm. So first of all find out the remainder. 121 more 10, it's a 1. Okay. So initially what is the value of reverse? It's a 0. 0 multiplied by 10 is 0 plus 1. So overall result is what? 1. Now 121 divided by 10. So it is what? 12.1. So integer of that, it's a 12. Okay. So 12 is greater than 0. Yes, condition is again true. So 12 more 10, remainder is what? 2. So previous reverse is what? 1. 1 multiplied by 10, it's a 10 plus 2, it's a 12. Now 12 divided by 10, it's a 1.2. So integer of that is 1. Again check, 1 is greater than 0. Yes, condition is true. So 1 more 10, 1. What is the previous reverse? 12. 12 multiplied by 10, it's a 120 plus 1, 121. And now 1 divided by 10 is what? It's a 0.1. So integer of that, it's a 0. Now 0 is greater than 0, no, condition is what? False. So what we need to do? Display the, first of all, reverse number, and now check whether the reverse number and its original number, they are same or not. If it is so, it's a palindrome, otherwise it's not a palindrome number. Okay. Again remember the importance of this step, because during this loop we are losing what? The value of n that you have accepted. Okay. And since we need to compare at the end what? The reverse value with a number that you have accepted. But since we are losing that original values inside this loop, what we have done? We have copied the value of n into the on, and finally we are comparing. Okay. Now to check a number is Armstrong or not. Okay, so what is the Armstrong number? When the sum of cube of each digit of a number is again equal to the original number, then such numbers are referred as what? The Armstrong number. Now you know very well how to find out the sum of each digit of a number. Now in this case what you need to find out? The sum of cube of each digit. Okay, so let's see. Assume the value of sum is 0. So accept the number. So preserve that original number. Now assume the number is 153. Okay. So original number will also hold what? A value 153. And now perform these 3 steps. What is that? First of all, find out the remainder. that is 153 mod 10, it's a 3. Now what you need to do, you need to find out what the cube of each digit. So 3 into 3 into 3, that is what, 27. And you need to find out what the sum of cube of each digit. So initially what is the value of sum? 0. 0 plus, it's a 27. So overall result is what? 27. Now 153 divided by 10, it's what? 15.3. So integer of that 15. Now 15 is greater than 0. Yes, condition is true. So 15 mod 10, it's a 5. Okay. So previous sum, that is what? 27 plus 5 into 5 into 5, that is 125. 125 plus 27, it's a 152. 15 divided by 10, 1.5. So integer of that, it's a 1. Now again 1 is greater than 0. Condition is true. Now previous sum, that is 152 plus 1 into 1 into 1, that is 1. So 152 plus 1 is 153. Now 1 divided by 10 is a 0.1. So integer of that 0. Now 0 is greater than 0. No, condition is what? False. Okay. Now what you need to do? You need to simply compare this number with the original number. If they are equal, it means that number is a Armstrong, otherwise not. Now of the other Armstrong numbers are what? 370, 371, 407. These are the sum of the Armstrong numbers. So you can try with this number and check whether you are getting the result Armstrong or not. Okay, that is the only way to practice. Now to find the sum of first and last digit of a number. See, initially what we have done, we have find what? The sum of each digit of a number. Now in this case, we need to find out the sum of first and only the last digit. It means assume the number is 123. So what will be the result? The first number is what? 1 and the last number is what? 3. So overall result will be what? 4. Okay, so we don't need to find out the sum of middle numbers. So let's check. And assume the value that you have accepted should be greater than 9 at the beginning. Okay, so accept the number. Now it's very easy to find out the last digit. How? Number mod 10 gives what? A last digit. For example, number is 153. Okay, so last digit will be what? It is a 3. Now number is greater than 9. Yes, if it is so, what you are going to perform? Divide the number by 10. So 153 divided by 10, it's what? 15.3. So integer of that, it's a 15. Now 15 is greater than 9. Again condition is true. Okay, so again 15 divided by 10, it's what? 1.5. So integer of that is 1. Okay, now 1 is greater than 9. No, condition is what? False. It means what? This is the what? The leftmost digit of the number. So now finally what you need to do? Perform the addition of this last digit with the first digit, and that is how you will get what? The answer 4. Okay, now and finally display the sum and stop. Take one more example. Assume the value of n is 987. Okay, so 987 mod 10, the remainder is what? 7. It means this is your last digit of the number. Okay, now how to get the first number? So 987 is greater than 9. Yes, condition is true. So 987 divided by 10. So it is what? 98.7. So integer of that is 98. Now 98 is greater than 9. Condition is again true. So again 98 divided by 10 is what? 9.8. Integer of that is what? 9. Now again go back to the loop. 9 is greater than 9. No, condition is what? False. So it your last digit is what? 7. And your first digit of the number is what? 9. So 9 plus 7, that is what? 16. And display that sum and stop. Now, to find the sum of positive numbers, no terms has been given. How many terms you need to find out? Okay, so again I am repeating the question. To find the sum of positive number, if the user enters a negative number, the loop should end. As soon as you enter a negative value, you are not supposed to perform any additions. Okay, so let's check. So initially assume the value of sum is what? 0. Accept the first number. Assume that number is a what? It's a non-negative. Okay, so assume in this case the number is what? 15. Now number is greater than 0. Yes, so perform the addition. So 0 plus 15 is what? 15. Now inside the loop again accept a new number. Assume it's a 6. So 6 is greater than 0. Yes, condition is true. So perform the previous sum plus 6. So it is what? 21. Again accept a new number. Assume it's a 9. Okay. Now whether 9 is greater than 0, again condition is true. So previous sum plus 9, that is what? 30. Now assume you have accepted a number minus 5. Okay. So minus 5 is greater than 0. Now condition is what? False. So loop will terminate and now print the sum, that is what? 30 and stop. Now here we don't know after how many numbers someone is going to enter a negative number. Okay, someone may enter the second number as a negative number, someone may enter after 100 numbers a negative number, someone may enter a negative number after 20. In our case, we have entered this number after 3 numbers, that is 15, 6 and 9. So exactly we don't know when someone is going to enter a negative number, and hence such kind of problems is not possible by means of what? A for loop. Okay, because remember, if you want to use a for loop, there should be 3 things: the initialization, condition and step values. If you don't have, go with the while loop. Okay, now the another format of while loop called as while one. Okay, so what is the while one? While one is same as what? While true. It means loop forever. It means this steps is going to be executed continuously. So in short, we can say that it is what? Infinite loop. So in order to terminate that infinite loop, what should be there? There should be statement inside this looping statement which is going to terminate this loop, and that statement is what? A break statement. Okay, so let's take one example in order to get an idea how this particular statement works. Now to find the number of terms required in a series before sum exceed 18. Now here we are not accepting a number, the number of terms that you would like to print. Here the question is what? You are going to perform the additions of each number as long as the number is not going to be exceed 18. Now it may be 18, it may be 20, or it may be 25, or it may be 937, any number, we don't know exactly. So it means as long as this condition is true, we are going to perform the addition. The moment this condition becomes false, okay, the loop will get what? Terminate. So let's check. Assume initial value of sum is what? 0. Okay, and assume the value of k is initially 1. It's a counting. Okay, 1, 2, 3, 4. We need to generate the number. Okay, so while 1, it means as long as condition is true. So it is always true. But inside the loop, you should have a certain condition which is going to terminate this loop. Okay, so let's check. When you want to terminate this loop, when the sum value is exceed 18. So let's check. What is the value of sum initially? It's a 0. Okay, what is the value of k? It's a 1. So 0 is greater than 18? No. If it is no, what we need to perform? We need to find out what? The sum. So 0 plus 1 is now 1. Now increment the value of k, that is counter. Now k become 2. Again go back to the loop. While 1, condition is true, yes. So 1 is greater than 18? No, because our value of sum is what? 1. 1 is greater than 18? No. So perform the sum. So what is that? 1 plus 2. Now it becomes 3. Okay. Now again increment the value of k by 1. So it becomes 3. So while 1 means true. What is the value of sum? 3. 3 is greater than 18? No. So again perform the sum. 3 plus 3 is what? Now 6. Okay. Now again increment the value of k by 1. Now what is the value of sum? That is a 6. 6 is greater than 18? No. So 6 plus 4. It is a 10. And increment the value of k by 1 again. Okay. Now again go back to the loop. The condition is true. What is the value of sum? It's a 10. 10 is greater than 18? No. So what is the value of sum? It's a 10 plus value of k is 5. So 10 plus 5 is what? 15. Now again increment the value of k by 1. So it becomes what? 6. While 1, condition is true. What is the value of sum? 15. 15 is greater than 18? No. Okay. So again perform the sum. So 15 plus 6 is what? 21. Okay. And now this is an important step. Now the increment the value of k by 1. So it becomes 7. So while 1, condition is true. Now inside the loop, here check. What is the value of sum? 21. 21 is greater than 18? Yes. Condition is what? True. So break. Okay. The value of new sum is what? 21. 21 is greater than 18? Yes. Condition is true. True means what? Break. So break does what? It simply terminates the current loop and control will be transferred to the next statement that follows what? A while loop. Okay. So how many terms you required in order to cross this number? You will require only 6 terms. That is k minus 1. Okay. And finally print the sum, that is 21, and stop. Okay. So understand the importance of while 1. It means this condition will be always going to be hold true. So there should be one statement inside the loop that terminates this particular loop. Okay, because we don't know when that particular value is going to cross this limit that you have specified over here. And now finally, synonym of for loop to while loop. We have seen so far two kinds of loop. The one is for loop and second one is what? While loop. Now question arises, is it possible to solve the problem that we have solved using the for loop using a while loop? So of course yes, you can convert all the problems that you have solved using the for loop using a while loop also, unless you have not used any break or continue statement. Okay, but the vice versa may not be true. It means the problem that you have solved using the while loop may not be possible to solve using the for loop also. Okay, so let's check the format of both the statement and how we will be able to convert, or what are the steps that you need to remember while converting the for loop problems into the while loop. So we know the for statement. For statement usually consists of what? The initial value to final value and certain step values. Assume in this case it's a 1 to n. And if this condition is true, it will execute what? A looping statement, and this process will be continue as long as the value of I is not going to be what? N plus 1. The moment the value of I becomes n plus 1, the control will take place. The control will be transferred to the next statement. Okay. So this is what your final condition. Now how we are going to convert this for loop into a while loop? So initially, what is the first step? Initially the value of I is what? 1. Okay, then what we are checking, whether the value of I is less than equal to n or not. Okay, so write it, then perform the looping statement condition as usual. So it means we are simply converting all the looping statement that you are written in a for loop in a while loop also. And finally what we are doing, we are incrementing the value of I by what? 1. And now what we have done, we have simply converted the for loop statement into a while statement. So remember what you need to do. Initialize first, then check the condition, then all the looping statement, and finally the step value at the last statement of your while loop. Okay, by following this approach, you will be able to convert all the problems that you have solved using the for loop using a while loop also. Okay, now take an example to display a message hello n times. So we have already solved this particular problem. So accept the value of n because it is an unknown. So now for I equal to 1 to n, what you are going to do? You are going to display the hello message one by one. So initial value of I is what? 1. 1 is, assume the value of n is 3. So 1 is less than 3. Yes, hello for the first time. Then the value of I become 2. 2 is less than n, that is 3. Yes, so hello for the second time. Then the value of become 3. 3 is less than 3. No, it is equal. So again hello for the third time. Then the value of I become what? 4. 4 is less than 3, no, condition is false, so stop. Now the same problem using a while loop also. So again accept the first number, then initially value of I is what? 1, then while I is less than equal to n, what you are going to do? Display the hello message and then increment the value of I by 1, and this process will be continue as long as this condition is true. The moment this condition becomes false, the control will be transferred to the next statement that follows the while loop. In this case it's a stop. So like this way you are able to convert a problem that you are written using the for loop using a while loop. So dear friends, in the today's session we have seen why while loop is required and when to use for loop and when to follow the while loop. Then we have seen the statement or format of the while loop and while one true statement, and finally we have ended with how to convert the problem that you have solved using the for loop using a while loop. So I hope that you understood all the point that we have discussed in the today's session. Practice it, that's all. Okay, so thank you very much, have a nice day.